Hello and welcome to another exciting edition of Anatomy and Physiology with Mr. Zabel. In today's lesson, what we're going to be looking at is the skeletal system. And in this unit, we're going to be looking at the bones and the joints. But for today, what we're going to do is just get a basic introduction of all the bones and the structure of our skeletal system. So you probably have figured out with every unit, we're going to always begin the unit by looking at the functions of that system. And the skeletal system is going to be no different. And so let's look at the skeletal system and the function of it. The first function we have for our skeletal system is support. Our body helps support us. Okay? It's going to be the framework and the scaffolding we need to attach muscle, attach tissue to, but it's going to give us our posture and everything else. So it's going to help with support for our body. The next thing it's going to be involved in is with protection. And so if we look at our ribs are going to help protect all of our vital organs, our lungs, our heart. We have all of our very important organs encased in our rib cage. Our skull is going to be very strong and it's going to protect our brain. And so we want to use the skeletal system as a means of protection. We also use it as a leverage system for movement. So again, remember we have muscles attached to bone through tendons, and that's going to cause movement. So when we attach muscle and tendons to this and ligaments, we're going to have movement which will occur. It'll help with mineral storage. So if we were to take a look at a bone, we can see that inside of this bone, we are going to have minerals that are going to be stored within. We're going to have calcium that will be in here. We'll have different ions that will be in this bone as well. But it's going to be primarily a source of mineral storage. We'll also have blood formation. So blood cell formation is going to occur within our bones. So when we look at your red bone marrow that's going to be inside of our bone, that's going to be where we start and make our red blood cells that will eventually fuse out of our bones and then get into our bloodstream. So cartilage also plays a major role in bone development. When you were little, you were mostly composed up of cartilage. And so this was very grateful to your mother. Your mother was probably super excited that you came out more collagenous than being more fully bone developed. If you came out more bone developed, she would have been in a lot more pain than she already was because she would have had to push that much harder and you wouldn't have been as flexible coming out of your mother. So again, your mother, when you go home tonight, make sure you thank her for giving birth to you because she really had to endure quite a bit. And I know from firsthand looking at my wife going through labor. And so again, you were made primarily of cartilage because it serves as bone model. And so eventually this cartilage is going to turn into bone through a process called bone ossification. And so it's kind of just our model or template before it becomes ossified into fully functioning bone. Cartilage is also important because it helps with smooth joint surfaces. So you have more cartilage that will stay at the joints because you're going to have more of bone rubbing on each other. So you want to have this cartilage to kind of absorb that cushion or shock. And then finally, it will help and aid in support. So two functions that we went over with the skeletal system include assisting with movement and structural support. And so two terms that I want you to know that are going to aid in that is the term tendon and ligament. I want you to know the difference between them because it's very important. First of all, I want you to know that tendons attach muscle to bone. So our classic example is over here with our Achilles tendon. Again, this is going to be from our heel to about where our calf is. So you have this muscle of your calf, the gastrocnemius would be up here a little more, but you have this long tendon that's going to attach your muscle to the heel. And so we have this muscle to bone. And so that makes up our tendon. We also have ligaments which attach bone to bone. And so they don't provide as much movement, they have more of a support mechanism, but you have these ligaments that are going to attach bone to bone. Tendons have a little more movement with them compared to our ligaments. So let's look at the composition and the makeup of our skeletal system. The skeletal system is going to be composed up of 206 bones. And when we look at it, it's going to be made up of bones, cartilage, tendons, and ligaments, are all types of different connective tissue found within our skeletal system. If we look at your skeletal system as a whole, we're going to see that it's broken down into two major divisions, our axial skeleton and our appendicular skeleton. The axial skeleton is going to basically be your skull, vertebral column, and rib cage, which will help support the central axis of our body. That's why we term it the axial skeleton. The appendicular skeleton is, think of your appendages. They come off your axial skeleton. So this includes your arms, your legs, your pelvis, and your shoulder. So here we have an illustration of your skeletal system, and you can see that it's broken down into your axial skeleton, which is in green here, and then it has also in purple your appendicular skeleton. Your axial skeleton includes your rib cage, sternum, vertebral column, and skull, and then hanging off that is your appendicular skeleton, which is going to be all the bones in your arm and wrist and hand, and all the bones in your feet, your pelvic bone, and then also your leg bones as well. So in general, these are some of the skeletal bones that I want you to know. Of course, we're going to get more in depth, and there's going to be more bone structures that I want you to know, but in general, these are the ones I want you to know. The skull, which is here, the mandible, which is your jaw, you have your sternum, which is going to be right here, you have your ribs, you have your vertebral column, your sacrum, your pelvic bone, or coxa, you have over here your clavicle, your scapula, which is going to be your shoulder blade in the back, you have your humerus, your ulna, your radius, your carpals, metacarpals, phalanges, femurs, patella, tibia, fibula, tarsals, metatarsals, and phalanges. Again, these are just some of the basic general ones that I want you to know, but we're going to, of course, go more in depth, and there's going to be more that I want you to know. When we look at your bones, there are four major classification or four types of bones that we classify them into. They classify into long bones, short bones, flat bones, and irregular bones. Long bones are going to be the very long ones that look kind of like this, like your femur or your humerus, but they're very long, so that's why I classified them as long bones. Short bones are going to be the bones in your hands and in your feet. They're very short. You have many bones that are composed up of your hand. Flat bones are going to be like bones like in your skull. So when we put your skull together, it has all these flat, thin bones. Your ribs are flat bones. Your scapula on your shoulder blade, that is also another type of flat bone. And then finally, we have irregular bones, which are kind of don't fit any of these categories. So they're going to be odd shaped. And so these are going to be like your vertebrae. A lot of your facial bones are just kind of odd pieces, and so those will be considered irregular bones. So next we're going to look at bone structure of an individualized bone. And so to do that, we'll look at this femur bone here, and we'll kind of locate the different key components to it for each and every single bone, because each and every single bone will have these basic components to it. The first component we're going to look at is called the diaphysis, which is the central shaft of the bone. And so if we look at this image down here, we can see our diaphysis is going to go from here to here. And so this large part right here makes up the diaphysis of the bone. And so if we were to look at this femur, we could see that our diaphysis is going to be the shaft of the bone, which is going to be right here. The next one that I want you to know is we have what are called epiphysis. Epiphysis are at the ends of the bone. And that's just from here, the end of our diaphysis, to the end of our bone. So that's one epiphysis, and then you're going to also have it on this one as well. So at each end you'll have an epiphysis. And so if we take a look here, this right here is going to represent an epiphysis, okay? And then this over here will represent another epiphysis. At the ends of these epiphyses, they're going to have cartilage. And so this is called articular cartilage. Articular cartilage is just going to be at the ends. And the reason we want to have this is because we're going to have a lot of rubbing on another bone, because it's going to be attached to another bone. There's going to be a lot of movement at this point. This is where a joint is going to be located. And so you want to have this cushion because it's going to help prevent that rubbing bone on bone. And it's also going to help with absorbing shock. So when we take a look here at your bone, you're going to have articular cartilage here, because if you think about it, this is going to be your femur. It's going to be popped into your, it goes this way, it's going to be popped into your pelvic bone. And so instead of grinding bone on bone when you walk, you're going to have cartilage here that will help absorb that cushion and kind of be a barrier between the other bone. Okay? And so then you're not getting all that pain. The last component that I want you to know is called our epiphyseal plate, or your growth plate. And you'll be able to see that it will be a line that's kind of in our spongy bone, which we'll talk more about next. But your spongy bone will have this line in it called your epiphyseal plate, or your growth plate. And this is going to be important when we look at how much you're going to grow. Some other terms that I want you to know is called the periosteum. The periosteum is going to be this dense connective tissue layer that covers our bone. Okay. Remember we talked about the periosteal membrane? Well, that's going to be composed in our periosteum of our bone. Okay. So if we took a look at your bone here, this outermost covering is called your periosteum. If we go and drill further into it, we can see that you have another layer because you have this hollow cavity in the inside of our bone. This next layer is called our endosteum. Okay? So our endosteum is going to be the second layer that's going to line the inner medullary cavity. Okay? So this inner layer is called our medullary cavity. Your endosteum is going to line this component of it, and your periosteum is going to line the outermost region of our bone. So next we want to talk about the medullary cavity. So inside of our bone, deep within it, you have the central canal called the medullary cavity. And your medullary cavity is just going to go from one diaphysis to the next diaphysis of the bone. And inside of your medullary cavity, it contains yellow marrow and red marrow. Yellow marrow is going to be mostly fat that's within the bone, and red marrow is going to consist of these blood-forming cells. And so this is where blood cells are going to originate and form, is inside of this red bone marrow. And then again, eventually they'll come out and they'll get inside of our bloodstream. But again, this is where the formation of blood cells occur. If we look at our bone structure, we can see that there's different types of bone material that makes up the bone itself. We have compact bone and cancellous bone. Compact bone is going to be solid bone material that's going to be located in the diaphysis of the bone. And so the central shaft, the diaphysis, will contain compact bone. It also contains inside of here the Haversian canals, which supply blood flow, and it supplies nerve cells as well. So that's why if you were to actually break a bone, you're going to see blood will be innervated there, so you'll have blood vessels that could rupture, and you also have nerve cells, and that's why you feel pain when you break a bone. If we look at the ends, you have what's called spongy bone or cancellous bone. That is at the end, and again, this is going to be important because it's going to be at the epiphysis, and this is where you're going to have to absorb shock. So when you jump up and down, you want to have this spongy bone, and it's called spongy bone because it looks spongy with all these little air pockets, and that's going to help absorb shock. So let's review everything we've talked about with this bone structure. Again, we have three major parts here. We have our distal epiphysis, we have our proximal epiphysis, and then we have our central diaphysis. Remember, we have these layers that make up our bone. We have the periosteum, which is on the outermost part of our bone, and then the inside, lining our medullary cavity, we have our endosteum. The medullary cavity is centrally located in the diaphysis, and remember, it has the red bone marrow and yellow bone marrow inside of it. Then if we look at the types of bone that we have calcaneous bone or spongy bone where the epiphysis is, and then we have our compact bone where the diaphysis is. If we look then at the ends in our spongy bone layer, we have what's called the epiphyseal plate or epiphyseal line, which is our growth plate. And that will determine how big our bone will actually get. And then finally, on the outermost part of our bone, we have articular cartilage. And the articular cartilage will just prevent bones rubbing on other bones. Well, that concludes our lesson for today. I hope this was a helpful podcast. And until next time, remember, keep studying anatomy and physiology.